I'm going to use Person of Interest, a TV show, to explain how developmental networks work. In this episode, we have to express Leon, or save Leon, from being eaten by Bear. So the way that this works is that the machine contacts Harold, or activates Harold. Harold activates John. John represses Byron, who, if was not repressed, would activate Bear, and then Bear would have repressed/eaten Leon. Now let's see what happens if we have a single mutation in any one of these proteins. Say, for example, the Harold protein is mutated and no longer works. The machine tries to contact Harold. Harold would then try to activate John, but since his protein is mutated, he can no longer activate John. John can no longer repress Byron. Byron would then in turn activate Bear. Bear would then be able to repress Leon by eating him. Therefore, Leon dies in this situation. Now what if we had a different mutation? Let's say Byron got mutated. The machine would contact Harold. Harold would then activate John. John would then go to repress Byron. So Byron can no longer activate Bear, and Bear will no longer repress Leon, who will live. But in this scenario, Byron cannot activate Bear regardless of the presence of John or not, since his protein is mutated and cannot activate Bear. Now what happens if both the machine and John are mutated? Harold won't be able to be activated because the machine won't be able to activate Harold. Harold would not be able to activate John, and then that would mean that John would not be able to repress Byron. Byron would then activate Bear, and then Bear would eat Leon. Let's do another one. This time Bear and Harold proteins are mutated. So the machine tries to activate Harold, but since Harold's protein is mutated, he can't activate John, which in turn means John can't suppress Byron. That means Byron can activate Bear, but since Bear's protein is mutated, Bear can't suppress Leon, so therefore Leon can be expressed or survive.